Hi, so let's say you worked on a machine vision application, you've developed this in your lab and you're now ready to deploy it on a production line. So let's see how the scenario plays out. You go there, you install it, you have this running, and you're really excited because the initial results that are coming on is very similar to what you've seen in the lab environment. But after your first day, you come back and then you look at your results and you see a very different story. Let's say, your accuracy that you were able to generate in the lab was like 95%, but on the production line, it drops to 80. How do you deal with this? And why does it happen? Hi, my name is Raghava Kashyapa. I'm the CEO of Qualitas Technologies. In this video, I'm going to talk about how, initial models that are developed either in the lab or piloted on a production line tend to drift in terms of accuracy, and why and how you can actually overcome this. So fundamentally, when you talk about any kind of vision application, you start off by developing an application using some kind of a representative sample. Either it could be a limited set of samples that are sent to you, which you worked on in a lab environment, created an image acquisition system, developed any kind of image processing solution using any third party or your own developed software, and then you're going to deploy the same prototype or system that you've developed in the lab onto the production line. But image processing system, especially when it is in a machine vision industrial environment, are very sensitive to changes. Why is that? Because the accuracy that you're tuning this for is very, very high. So the accuracy demands for a vision system is, has to be near perfect, because we're talking about, Six Sigma types of qualities. Manufacturing quality is, has huge demands and pressure in order to make sure zero defects are, exiting from the assembly lines. So that leads to tremendous sensitivity issues when it comes to vision. And so once you've developed something and you produce on the line, these subtle differences, let's say changes in lighting, changes in texture, maybe it's just the working distance, or maybe even, just how, the angle is oriented compared to what it was done in the lab. All of them can have some difference and impact when it comes to your final accuracy. And worse still, you may actually have tuned this in, let's say, to a very high degree of accuracy in your first phase of deployment, but due to some external change that happens later. So let's say there is some change, either there's some disturbance in the mounting arrangement, or there's some change in the texture of the part, or maybe the lighting has degraded a little bit. Whatever it is, there's something that causes what we call image drift. What is image drift? It's the drift of the quality of image from the original trained solution to what to deviating from that original trained quality, is now deviated or drifted from that represented golden sample. Now when that happens, your model accuracy, if it's with AI or with even rule-based systems, is the results are also going to drift, and you're going to see a different set of results or accuracy numbers. So we at Qualitas, we handle this in a couple of different scientific ways. One is we've developed a platform called the Eagle Eye platform that we deploy it, and we are on a regular basis sampling each images as they're being produced. So it's like think of it as a QA for the QA system. So when we do the sampling of these images, we're able to then compare it proactively with the golden images. And so if there's any changes in terms of, let's say, the brightness or the focus area or maybe the angle or whatever it may be, it flags up an alert, because that's kind of the first warning signs that the solution, the processing is also going to then start to deviate. So the second way in which we can proactively analyze drift is by proactively and regularly measuring accuracy. So with those sampled images, it's presented to a human, an expert who is able to then qualify whether the system accuracy, that is, what is inferred by the system and the software, matches that of a human expert. So when the two tally, that means it's an accurate inspection. If it's not tallying, then it's got an error. And with those samples, either images that have drifted from the original sample, or it could be a low confidence in the inspection. So you take those samples and you presented that to a human, and then you're able to really identify, okay, what is the accuracy drift or the model drift that you've also encountered, and the interventions based on that could be a natural progression. So if there needs to be an image acquisition correction, you go in and you change the setup, or you fine tune the setup, or if you need to retrain the model, you can then use those images to retrain the model and make sure that those edge cases that you hadn't earlier considered has now been incorporated. So with any vision inspection system, it's great to have the first set of deployments, but think long term. Think about how you're going to deal with image drift, model drift, and how you're going to make any interventions to ensure that the drift is minimized, so you're not very reactive, but a little bit more proactive in maintaining the accuracy of the system. Hope this video is useful. Thank you.